Right? Another Java class. We're doing chapter 8, which is interfaces and polymorphism. We're going to do lots of examples, and then I will try to do a studio intro. Interfaces and polymorphism. So just some more definition things so that we can get that out of the way. Polymorphism, object-oriented mechanism that allows for objects of different types to be used in the same way. So there's usually like a category. I think of it like a category of items that things fit in. And then instead of each of them having to do their own thing, I'm going to put them underneath like an umbrella, per se. Polymorphism is a concept in programming where objects of different types can be treated as objects of a common superclass. We were talking about cats before. Whenever you're doing, your house cat versus a tiger, since they're both cats, you can treat them both certain things of them just like a cat. So it allows you to write code that works with different types of objects more in a unified way. Like we're doing the cat, if you wanted to say that it, well, I think on this thing it'd probably be better with animal. If you have an animal, you can have a cat and a dog. Well, all animals have certain traits. And that's where we're going to try to get in the differences between like an abstract class. That's why I went up a little bit higher to the animal class rather than the cat class, because I think the cat would probably be better as an abstract class, where an animal, though, is so vague that you usually do more of an interface for that. So we'll talk about those. And there, if you want to know the 4 pillars of object-oriented, I left them on there so you can see those. Interfaces, they're a formal construction in Java. Interfaces allow us to create a set of behaviors, but they don't actually implement them. So it's saying that an animal has to have a weight. Like it has to have a size. It has to have, certain things that animals have to have. Animals have to eat. So, you can do that. But what do animals eat? Well, that could be different for every single animal. We have carnivores and herbivores and omnivores, I think, are the ones that are in between. So you have different types of animals. Well, an animal, if you described an animal, you're just going to say that it eats. You're going to leave it very, very vague. And then within each animal class, that's when you're going to say, a tiger is a carnivore. And then you can actually implement those things within the actual classes. The things that you can have in an interface, you can have constants. These are static final fields. You don't actually put static final in there because if it's in an interface, it just knows that. So you just put string, the variable name, and then whatever it is, and it just stays that way for everything there. You do method signatures. I don't think we've actually called out the name of a signature, but it's just the heading line. So it's usually the public with the type, so like string, and then the name, so like get name, and then the parentheses, and then what parameters get passed in. So that right there is the method signature. It's not actually what it does, it's just the header or the signature of the method. And you define those in interfaces, but you don't actually implement. There's no coding underneath there. There's no curly brace with action steps underneath. You can implement static methods. So those are, remember, static means that you can pull it without actually creating an object of it. So static methods can be in classes, abstract classes, interfaces. Static methods can be just about anywhere. So those are their kind of own separate thing. And then there is this thing such as a default method. I am not going to go into that very much. I have never written a default method. So I know what it is, but it's not very important for the level that you guys are at. Some benefits, these are pretty much copied and pasted from the textbook. But Some benefits are you can implement multiple interfaces rather than just one. You can extend a class and implement an interface at the same time. So you can have an abstract class that you extend and implement interfaces at the same time. By declaring variables in parameters and interface types, it makes your code useful in a much wider variety of situations. This is where a lot of people are getting stuck on of like, why would I even do this? Like, how is this really helping me? And unfortunately, we are 7 classes in, so that's like 3 weeks into Java, and you guys are talking about complex Java in 3 weeks. So unfortunately, you don't have a lot of the background knowledge and just experience that it takes to understand this better. But what I'm going to tell you is, to get a job, you don't need to know how to implement these as much as memorize the vocabulary. You might have an interview that says, hey, what is polymorphism? And as long as you can read off the textbook answer of it allows multiple classes to look like the same class and interact in the same way, then they're going to be like, okay, good. And then they're going to move on. That's all you need to know as an entry level is just the vocabulary and the definition, and that's it. These are more complicated, more complex things in Java, but you have to at least have heard them before. As a side note, the good news is next class, we go back to something very concrete and very easy. So this is probably the most complex we're going to get in Java. After this, we actually go back easier. So, and then that bottom point is the same type of thing. The whole point, the whole reason Java got so big so fast, well, there's two. One thing, Java was language operating system independent. So it creates its own JVM, so it can go on any device that you want to. That was the main reason it got out. And then secondly, this idea of object-oriented programming, whenever we talk about like SQL databases, relational databases, and how people think in a very structured way, I'll also bring up during then, it's this way with every single concept. There's one extreme that is extremely structured, and then there's the other extreme that has absolutely no structure and you can do whatever you want to. And to be honest, JavaScript is the one that is not structured at all, and then Java is extremely structured. So they are total different mindsets whenever just the programmer's using them. Kind of think about it. On the other hand, both of them have tried to meet in the middle, such as JavaScript now has TypeScript that you can start structuring it really well. There are different methods. I probably will not talk about them until right at the end of Unit 2 because you need to hear like the core Java stuff first. But there are ways in Java to make it more functional. So it's not as structured. You could technically use var almost anywhere in Java and it still works. On the other hand, on the underside of it, even though you say var, it knows if it's a string, it knows if it's an integer, so you still can't manipulate it like you just, it still kind of strongly types. It's just a little faster for typing, but both of them are trying to make it good for the other. This screen here, the interface is everything on the left, abstract's everything on the right. So interface and abstract, on both of them, an abstract class or an interface cannot be instantiated, such as if I say interface animal, I cannot say new animal anywhere in my code. If I say abstract animal, I cannot say new animal anywhere. So those are the same. The purpose of interfaces and abstract classes are to remove you from the concrete and bring you to a level of abstract. Your interface, even though they don't call them abstract methods, every single one of them is abstract, meaning abstract means it's not implemented. So none of your interfaces can be implemented in your actual interface. On your abstract, there's some of them, we can implement them if we want, or we can do the keyword abstract, and then we don't have to implement them in our abstract class. So you get to choose there. Same thing with being able to do it. Methods cannot be implemented. So these abstract methods and implementation mean the same thing. So if you have an abstract method, it cannot be implemented. On abstract classes, because you can define them or you can say they're abstract, you get to choose. Because they cannot be implemented on the interface, that means that they must be implemented in the actual class that they're called. So if I say interface animal, and then I said speak, that means if I implement that anywhere, like on Tiger, and I say Tiger implements animal, I have to then define that speak method, or else it'll throw an error. If the method is already implemented, what's it really doing? If it's already implemented, then it doesn't have to be re-implemented. It can be overridden, but it doesn't have to be re-implemented in your class. Access modifiers, all of these are public, but on your abstract, because it's like that blend, your abstract class is your blend of an interface and a class. You can still make them public or you can make them private. Even though this says you cannot have member variables or fields, meaning, let's say that I wanted to make, like on the quiz, point values. Well, every quiz question could have a different point value. So that could not be an interface variable, because the interface variable is going to ask, well, how many points is this worth? And you can't do that on interfaces. Interfaces on variables are either static and final, meaning that they are what they are, such as if you wanted to do, I think I saw somewhere like the temperature, like the absolute zero, that never changes. So yeah, you can throw that into an interface because it never changes. But on abstract classes, they can have member variables. And we saw that with the quiz question. You could have point values on those questions. Classes can implement multiple interfaces where they can only implement one abstract class. So those are the key differences between those. More vocabulary. And again, for you guys, I would not use the default method. There are default methods that you'll see around, but I wouldn't implement them. Polymorphism, that's where, if you have an animal and you have a cat and dog, you can treat the cat and dog the same way if they both implement the animal, because they're all animals. So anything that the animal can do, all of the animals can do. So you can treat them all the same. The interface is that abstracted layer, kind of like an abstract class, but it's all the way abstracted where you can't really set anything in it. You're just setting the structure. Method signatures, again, I mentioned that was just that top line of any method. Default methods, they have them in interfaces where there are implementations. That's where a lot of this stuff gets confusing. Interfaces in general should not have any implementation, because you have old code like Java 7 into Java 8. There was a lot of reworking of things. So then they allowed for a lot of default methods, but for you guys, don't do them. And then we talked about abstract. In general, abstract is removing that layer of concrete. So it's thinking higher level. And then the book does talk a little bit about testing interfaces. Because we don't do a lot of test-driven development in LaunchCode, you need to at least have seen it. But again, that's not going to be something that you're going to be questioned right out the gate to get a job. So I'm going to... So a good question. Static methods, are they technically abstract? They're technically, static methods, I would almost argue, cannot be abstract. So abstract means that you don't implement it. where static means that you've implemented it in a way that you don't even need to create the object. Let me write that down, and if I can come up with I want to show that in code. Okay. So I'll show you what the compiler does on those. How do we use the abstract class in another class? Yeah, don't set them to private. I don't know. Once they're private, you can't do anything about it. And I don't know about bio or computer sci. I don't know what you're asking there, but I thought there was a second question that I was going to put up here, but I can't remember. I don't think I think it was in the homework thing, and that's why I forgot to copy it over. But somebody did ask in the lecture questions, why did we use override with the cone comparator rather than the double compare? And to be honest, whenever I did it myself, I did the double compare. So I think they were doing it just to show you and teach you, but you're right. To be real world and as efficient as possible, I would use the double compare. And I will be showing my code for that. I think today's the 22nd. Yep. So graded assignment 1 is due today. So hopefully you guys are scheduling those code checks with your IAs. I had some people ask some great questions. I do feel like a lot of the questions that I've answered, I don't think was out of reach from anybody. It was just, I think, more of a confidence. And like they just needed that one little tiny bit. So I don't think it was terribly difficult. A lot of people that I heard back was like, yeah, this was actually not too bad once you got into it. So again, that's why I'm stressing the fail fast. On Thursday, I will show you a rundown of the graded assignment 2. I don't think you'll have as long to do it. I think it's just like a 2.5 week turnaround. But I will definitely show that on Thursday. But yeah. Last comment. Not just with the fail fast, but I feel like less people are posting things in Discord, but that is not proportionate to the number of questions whenever I'm listening in studios that people are asking. So what that's telling me is people are not asking questions on Discord, but they still have questions. If you are that person, I need you to start posting more questions on Discord. What that does is 2 things. It helps everybody else in this group. I don't know how many times, if you look at the homework help right this second, there's at least 2 or 3 people that have said, thank you for posting this because it helped me a lot. So even if you solve your own question, but you had the question, you spent 2 hours, and then finally it popped up, you can answer your own question, but ask the question in homework help and then maybe even answer your own question in homework help. But those things are going to help everybody else out in here. Secondly, and more important for me, I need to see what people are struggling with. I didn't know until I was hopping around in studios last week how far behind people at least thought they were. I need to know that information. So please post more stuff in Discord so that I can tell where you guys are at, so I know like how I can help you better. Okay. Let's try to do some coding. Again, I'm going to separate this out. So we're going to do a nice, about 20, 25 minutes of coding. I think the first thing I'm going to do is this, the exercises. To be honest, I did them last week, so I almost forgot what I did. So I'll explain kind of what I did, but it won't be as good because I was working on something else. Okay, so here we go. Is this my, yes, my project? I will interfaces. I will zoom in here in a second. Right. So again, here's my ice cream exercises. I'm just going to start opening things up. It looks like the only thing I did was the two. So let's figure out. Well, actually, let me not open things up. You guys were asking how I kind of do things whenever I look at brand new code. Here's the first thing I do. There's two approaches that I have. I can look at all of the files and just scan them. I think that's sometimes overwhelming when you have all of this stuff. So then what I do is I go to the main, because that's where my code starts at. And if I go here, I start looking, and hopefully they named things appropriately so that I know what's going on. Such as, so I have a menu. I think I know what a menu is. And then I have a list of flavors. I have a list of cones. I forgot that I did this. This is that functional programming that I was talking about. I was talking to somebody and they told me about streams. This is supposed to make it, more like JavaScript. I will rewrite this here in a second so that you can see the more traditional style. But I did this for my own benefit because I am not used to streams in Java. I'm used to doing like a for each loop. But then there's this comparator, flavor. I'm going to sort it. And the same thing down here. Okay, so what I'm doing is I'm just scanning kind of what I'm doing. Obviously here I'm just printing out for each of the flavors. So let's see, what is a case? So if I just control and I can click on these things, if I control, click a case, well, a case has flavors and cones. I guess it's actually setting them right here inside this case. Flavors too, I can get set and set. So these are my setters and getters. Here's the actual stuff in my case. Seems pretty straightforward. Flavor, what is a flavor? A flavor has a name, a cost, some allergens. And then there's this super. Well, super means that there must have been an abstract class there. So what this is doing is it's getting from ingredient. So I'm going to go into ingredient. So ingredients is an abstract class. This is what I would assume. It's a name, cost, allergens. And then setters and getters and a toString. Okay, so toString. But these are just setters and getters. So really, a flavor and an ingredient, I don't think I saw anything added here. So a flavor is an ingredient. There's no additional things there. If I go to cone, a cone, look at that. A cone is also an ingredient. I don't know what they call an ingredient, but I would say like a case item, maybe. I don't know. Flavor, but let's do the cone and the flavors. So this for each. If I wasn't doing that, what I wanted to do is I just wanted to print out all the flavors. So if I did this traditionally, it'd be something like this. So I'm gonna comment this out. But so this right here would print out all my flavors. So for each flavor in the flavors, print out the flavor.getName. And remember, if I
Here,
did
just lay it on the side, bud.
if I do just flavor without the get name, this would print the memory location of my flavor because, well, actually, would it? Flavor has this. Does ingredient have a toString? Oh, it does have a toString. So this would not print out the memory location. I'm just going to go ahead, comment out a lot of stuff, and I'm going to run this. So if you look, it actually prints out the name, the cost, the allergens of each of these. And the reason it does that is because flavor extends ingredient, and ingredient has a toString. Here's a tool, here's a tip for you. Let's say that I wanted to know where the toString method was for my flavor. If I just type in toString and then control click on it, it will actually take me to the toString in the ingredients, and it'll say I'm going to do this toString. So if you ever want to know if it has a toString, you just type it up, toString, control click, and it brings you right to where you want to go. So this is how I would print out the flavors. The problem is, to match what the book was saying, I wanted to just do the names. So I'm going to say something like S out before, but I'm going to do just the name. So get name. I want to make sure this looks good before I go any further. And it says before this. Okay. So vanilla, if I'm doing it by order, vanilla definitely is not the top one there. So that's where we do these other ones. And then somebody was asking, well, okay, so something I haven't clicked in yet. So all I'm doing is I'm going line by line and saying, okay, do I understand what these lines are? If I hit a method, you know, get name, I don't have to look at the get name because I know what get name means. So certain methods I shouldn't have to look at. So let's talk about when I start control clicking on a comparator, it doesn't, I didn't make this. This is a generic, this is an interface. This is the reason why you need to know interfaces. It is not because you're going to be writing a bunch of them. It is because you might be implementing a few of them. So I looked at my code in my, like at work, to see where am I implementing certain things. And to be honest, I'm not implementing a lot, but I think the one that I'm implementing the most is serializable. We will go over that one way later, right at the end of Unit 2. You can serialize or deserialize information, text. So I will go over that one later, but that's pretty much it. I have not written any interfaces myself, but I have implemented other ones that have been written. So again, you don't need to worry about knowing it to the level that you have to write your own as much as implementing it. And then a good question that was asked is this T right there. So if I hover over it, I thought it said it. So it's just a type parameter, meaning it expects a type to go in there. But what type it is could be anything. So it's a thing called, and if you really want to learn more about it, it's called generics. So if you go to, you know, some kind of Java documentation and type in generics, you can actually create your own interfaces using generics, and do something similar to this. But yeah, all this means is to be able to implement it, you do need a type. And what is that going to do? If you look right here, this is what an interface should have. It's just the signature. It's saying what is going to get returned, the name of the method, and then what are you putting in it? And of course, the T means any type, but this type has to match this type. So whatever you put in for this type has to match down here. You do not have to use these variables, but these are the ones given, so most people do. But there's no implementation. It doesn't say what to do here. It just says compare. What this means is that you have to implement it in the class that you're calling it. Then the question is, this was something else that even I had to reaffirm that I knew. This Boolean equals, you see how this is just a method there. Well, this one, the reason we do not have to implement this one is objects in general. If you instantiate an object, it already has an equals method that comes with it. And it overrides this one. So this just ensures that if you try to do some random like int or something, you can't do that because equals needs an object. So you don't have to implement this one. This is where you start getting into the default. I don't know if you saw here, it says since 1.8, that means Java 8. So Java 8 has done a lot of these defaults. And it's because before Java 8, some of these things were around, but then after Java 8, they're like, hey, we don't want these anymore. So you can do a reversed, it'll let you do it. But default means that you can actually implement it in the interface. But again, do not do this. So I know that this is supposed to compare some things, and I'm supposed to have a sort, but my sort has to override. So I need to override my sort. No, sort is the array list. That was not what I wanted. I wanted to go into this thing. There we go. It was the compare. So whenever I'm comparing, I think this came straight from the book. When you have strings, so a get name is a string, the compare to with strings, it's going to do its alphabetical order. I think it technically does capital and then lowercase. You'll have to look at that on actually how it compares, but when I'm comparing two flavors, it's going to get the name of the flavor because remember, flavor has a name, a cost, and allergens. So whenever I sort them, I need to tell them how to sort it. Do I sort it based on the name, on the cost, or the allergens? And I'm saying get the name, which is a string, and compare to the string. This is why that great question of, well, whenever I do the cone comparer, what should I do here? And you can use the double compare because once you get the cost, it knows that there's going to be a double there, and it knows this compare function is already written for you. So you don't have to worry about it. On the other hand, if you're wondering how this compare function kind of works, compare functions in general either return a -1 or a 1. Meaning, is it less than the number or is it greater than the number? And then based on that, it goes through all of the things in the list and it sorts them based on just comparing them over and over and over again. So when you do the compare, it needs to know which one's less than, which one's greater than. Again, to implement this, I had to put cone. If I don't put a cone, it'll throw a big fit. And if I don't do this, it wants me to implement all of these things. Don't want to do that. All right. Going back here. I don't know if there really was much more to really show on this. Before it was this sorted chocolate, it's the alphabetical. Before this, the waffle, sugar, wafer, and bowl, and I sorted it by the cost. So the other thing, somebody said like a print line F. That's the same thing as like formatting here. You can Google this. I don't know about like. I have used this quite a bit. I have to Google it almost every single time. But this says go grab the string, go grab the float point and round it to 2 decimals. That's what this means. And so then the first thing is the string here, which is the name. This is the float, which is the cost. That's why down here it's the name with the cost with the colon in between. All right, I'm going to look at the questions real quick, see if there's any. I do have one more thing, and then we're going to take a break. Somebody's asking about the sorted array list. Yeah, I can show this. This is the one. I mean, I didn't want to reinvent the wheel. I just used the double.compare, and then you throw in 2 doubles, and it'll compare them. It'll return either a -1 or a 1. Technically, if they're the same exact thing, it would return a 0. So that's how you can tell if they're equal. If you have questions, you might have to reply them again or repost them again, because I get a lot of replies to the sorted array list. Yeah, if you remind me, if you ask the question in the lecture questions, I can probably remind myself to go over it on Thursday. Anything else on these? I want to go over the studio. This is what I'm going to do after break, is go over the studio. I think what I want to try to do is, with the time I have, I want to go over an example of more shapes. You guys know I love shapes, so we're going to do some shapes. Yeah, I think I'm going to do this before our break, and then we'll take a break. So what I wanted to do, and of course, this is me having a little too much fun and spending a little too much time on this. What I want to do is I wanted to make and also, if you are really advanced in math, do not take offense that I either copied or pasted or just made up my own formulas for some of this stuff. So I didn't want to spend it on that. I wanted to figure out how can I do the abstract classes versus interfaces and that kind of stuff. So don't think too much about my formulas whenever you see it. I don't know. You'll have to Google on what happens when it returns 0 on when it's comparing. Yeah, I don't use it, so I don't know. All right. So again, I'm going to go through, well, what is this thing even doing? The first thing I'm going to do is run it. So let's go here and let's say current file. Let me run this shape runner. I'm going to run this thing, and it says enter the type of shape. So okay, triangle's the first one. It's going to say enter side 1. Let's do 3, 4, 5. Okay. Sure. Let's enter another shape. Let's do circle. Also, I did not do any input validation, so I am typing in exactly what it needs. I don't have any like wrapper around these inputs to like say, oh, you didn't type one of the things. So don't read too much into that either. Enter the radius. I'm going to say 1. Yes, let's do another one. Let's do rectangle. And then let's do a 3 by 5. No, I don't want to. Okay. No, so it tells me all my shapes. I entered in a triangle that has an area of 6, a parameter of 12. It has 3 sides. I have a circle that has an area of this and a parameter of this. I have a rectangle, 3 by 5, so that'd be 15, and that would be 16, and number of sides. So this is all the information it's telling me. Do you see how in my main class, all I have is get shapes, and then I have display shapes? This is what I would consider a very good runner class, because in Java, the heavy lifting should not be in my main. My main is just to start stuff off. The power of Java is that everything else knows how to interact with each other. So let's actually go kind of line by line through this. So this get shapes from user input. When I go here, it opens up my shape abstract class. I don't think I did any interfaces. Oh, no, I did. I did a polygon. I'll show you that. So my shape has to have an area and a perimeter. So this is where somebody is asking about the static versus abstract. When I label a method or anything abstract, do you see how I don't even tell what it is? I don't have an implementation. And when I try to implement it, it says make area not abstract. So when you talk about abstract, you are not defining what's actually going on. You're just giving it a name. That's all. You're setting the structure so that other people have to follow this structure, meaning other classes have to have a double that it returns, and it has to be named area. That's all it's saying. It's not saying how to do it, just saying that it has to be there. So hopefully that answers the abstract question. Because then if I had a static, I have to add a method body. And if I add a method body, I get a lot of problems, because static means that I do not have to implement a shape. I don't have to call a shape. I can do shape.area. I can call shape.area without even creating a shape. That's what static means. Static, you do not have to create a shape. You can just say, go do it. So I have said in my shape, every shape has to have an area and parameter, but I am not telling it how to do it. Now, then the question is, these two things could technically be in an interface. If you have an abstract thing like this, and that's the only thing you had in it, it's not an abstract class, it is an interface. An abstract class, it can have abstract object or abstract methods, but it also has some kind of ones like this that have implemented methods in it. So what I did here is I said that the shape get shapes from user input is actually this method here. This method gets a scanner. It's going to create a list of shapes that I have not defined yet. I'm going to ask, hey, is this thing done? I'm going to say, no, it's not done yet. I'm going to do the do while, because I want it to act. I need it to ask if it has a shape before it actually does anything, before it evaluates. And then that's where you can see what I'm wanting. And then I'm doing a switch in case. The reason I'm doing a switch in case, two things. I've been reading up on this, and I guess switch cases are a little faster than if else if statements. And then secondly, if you have 4 different options like I have here, and it can only be one of them, it can't be multiple, it can only be one, that's the perfect example for a switch case, is you have one of the things that you want, no more. So I'm going to say When I make it lowercase, is it going to be triangle, square, rectangle, or circle? And if I didn't put anything, it would say invalid shape. And then if it's a triangle, it's going to do the shapes.add. Because I'm in, yeah. So the add is the list, right? And then it's going to create a triangle. Here we go. So I'm going to add whatever create a triangle means. You could have had a different scanner for each of these so that some people would say, well, the triangle class will have a scanner, the square class will have a scanner, but that's not very efficient. I only want to create one scanner and then just keep using it over and over again. It's a little bit more efficient that way. So I'm just going to pass in the scanner. So whenever I try to create my triangle, I go into here, it's going to pass in the scanner. It's going to say enter, scan, enter, scan, enter, scan. I did find out through some lot of Googling, when you do a next double, when you hit enter, it actually treats that as like the next line. Like it's a character that's not a double. So whenever I type in, hopefully this will make sense. When I type in 3 and then return, what that does in my system, it says 3 and then it does /n, which then in a scanner, the next double would grab the 3, but it'll leave the /n. I don't know if that makes sense, kind of. It did not, like, I didn't intuitively think that, but that's what happens. And so the /n keeps getting left. Well, the good news is here, next double, it leaves the /n, and this next double says, okay, what's the next double? And it ignores the previous /n, and it waits until there's another double. And then once I type in that double, then this one's waiting for a double. It does not allow it to go on until I type in another double. But then this one clears out that very last /n. So if you ever come across that, because you guys are messing with your own projects, just know that that's how it's going. And then I'm returning back to my create triangle where it gets called a new triangle with those sides. Well, what does a triangle have? Well, a triangle, it extends shape, which means it has to have an area and parameter. So remember, an area and parameter. But it also implements a polygon. So what's this polygon? I don't know if you know, but polygon means multi-sided. So I need to know how many sides there are. And the reason I put this one in there is because I can do circles, and circles are not polygons. Man, I'm going all over the place here. Circles are not polygons. So that's why I wanted to come up with an interface that I can show you that you have to, like, that's all it is. You're just declaring that it has to get a number of sides. My get number of sides for a triangle is 3. And again, here's some weird math to return the area, but we're not going to really focus on the math. If I know what the triangle is, the square is almost identical. It says create square. I only need one side, so I grab the double, consume the new line, and then make a new square. What does a square have? It just has one side. That's all it needs, because from there, it can get the area and the parameter, and it knows the number of sides. If it's a rectangle, I create a rectangle. Create a rectangle linked width. What is a rectangle? Length and width. Implements all those things. Well, the oddball is the circle. So what is a circle? Well, a circle just has a radius. It, because it extends shape, has to have this area and parameter. It has to, because it extends shape. But since it doesn't implement polygon, it doesn't have the number of sides. When I display the shapes, here's the interesting thing about polygon here. Whenever I display all the shapes, so it doesn't matter what shape it is, it doesn't matter if it's a polygon or not, It's going to print out the shape, the area, and the parameter. It's saying if the shape is a polygon, well, go ahead and print the number of sides. This casting right here, I don't think you actually have to do it. Oh, you do. Because you're talking about a shape. You're not talking about the exact shape. So here's your casting, those of you that are asking. I didn't say circle. I didn't say square. If it knew what it was, meaning if I said, right, because squares implement or extend shape, or because it implements polygon, if I know it's a square, I can just get the number of sides. That doesn't, like, when I go to square, the square class, it implements polygon, so then it knows that it gets that. It's already there. Whenever I talk about shape, shape does not implement polygon. So since shape does not implement polygon, whenever I go and do my check here, when I do my get number of sides, not all shapes have this method. It's not guaranteed. So that's why I cannot just do shape dot get number of sides, because not all shapes have this. Squares, rectangles, triangles do, but not everything else does. And then my other problem is, well, I can't always cast it to a square or a rectangle or a triangle because I don't know which of those it is, which is the whole reason we use abstraction. We do this like level above to say, well, all polygons do. Oh. All polygons have this. If I did not have this polygon right here, if I didn't say that squares, rectangles, and triangles have sides, but circles do not, I could not do this thing right there. Like there's just no way. I could implement it in the circle. I could implement it in the shape and then just give circle 0 number of sides. That is one way to get around it. But if I do not want my circle to have any sides, like I don't even want it to have that property, this is the only way that I can ensure that all of my shapes are taken care of with the number of sides. I don't know about you. I'm ready for a break. So here's what we're going to do. I'm going to start fresh. We're going to go to the whiteboard when we get back. I'm going to talk about questions, and I'm going to redo the studio that you guys did last time. And I'm going to do it the way that I would probably do it. Unfortunately, I have my final code. So whenever I'm doing it in front of you, I already know what it looks like. So I might skip some steps naturally just because I already thought it out. Where originally I was hoping to not skip steps for you. I was hoping to like have bad code for you so you could kind of see this is the first draft. Okay, how can we refactor this for a second draft? So I don't know how you guys want to do that, but what I'm going to do is I'm going to shut off my video and my microphone for, let's say, let's do 8 minutes. So my time, which is Central 6:40, I'm just going to mute and stop my video. And then about 1 minute before I start, I'll turn my video back on. So I'll be back at 39 after. Post questions if you want to. I'll read them whenever I get back. Okay. So I think the part of software engineering that some people overlook, it's one of the skills that we haven't explicitly called out yet, and I think that might be the problem that we're having is designing. You have to have a better concrete knowledge of what is going on and how to utilize the stuff that you've learned. And so that's what we're going to try to do here. We're going to try to do more designing. And again, once I get to the implementation of things, I'll kind of go a little fast because if we were all in person and you guys could watch me watch my screen and type at the same time, I know some of you can, but not all. So if we had that, I would probably do it a little slower where you could type along with me. But I think for this purpose, it's more for a demonstration rather than you typing along with me. So yeah, you don't have to type anything. If you want to write some notes down, that's fine. But don't think that you have to do a lot of typing. I'm going to go too fast, and I know I'm going too fast. That's not the purpose of this. So the first thing I want to do is just designing. So question, is there a job position in designing? I think you have to understand key design concepts. You don't have to be amazing at it, but you have to at least be able to understand when somebody else says, here's how we're going to do things. You're like, oh, that makes sense. You put this, like these things fit together. Now, if you're talking about like UI design, there are UX designers. I don't think that there's a lot of jobs out there for that right now, but there are UX designers that work with like Figma and design websites. They mainly on the UI side or UX, but no matter what, we have to. This is more of like a design of what we're doing, data, classes, those kind of things. The first thing I want to do though is I want to design. That again, hopefully you guys, and that's still a little small for some of you. I will try my best to make it bigger, but who knows? Okay, so what we are going to do right now is we are going to just think of, we are not going to program any of this. I did start to program a lot of this, but then again, I think it's just good to go through design. Let's say that I have a zoo. There are two different ways that people traditionally design. There are some people that take the whole entire big picture and then start categorizing and then start putting pieces in those categories. And then there are others that design kind of like the bottom up, where they want to know what are all the animals first. And then they say, well, what traits do these animals have in common? And then they start moving the animals around to then match what they have. Either design process is absolutely perfect. It's just making sure that then, like everything, you go through it once. You need to go through it as fast, not as fast as possible, go through it fast, and then do it again. So if all I'm doing is we're putting animals in a zoo, and then we are trying to abstract. So we're trying to use abstract classes and interfaces on how we can abstract some of that information. And there's many different ways that we can go. I'm just going to try to keep it simple with also designing. So if I have a zoo, I mean, I can have lots of different animals in there. I can have an aquatic center in there. You know, I'm not going to name all the different things. But hopefully you guys realize there will be different subsets inside the zoo. First of all, I think the majority of things that are in a zoo are probably animals. I'm going to put animals. There are a subset of things in the zoo that are just pretty. And they could be plants. Planets or plants. So again, we could come up with all different types of things, but these are the main categories there. And within animals, I'm just going to go with the theme of carnivore and herbivore. But this is where it starts getting very interesting. If I do, that is 100% not how you spell that. You guys are going to see how bad. Is that actually how you spell it? That looks so bad. Carnivore. Okay. And then the opposite of carnivore is, that's what it is. It's an I. Somebody, there we go. With an E. All right. And then the opposite of that is herbivore. If I spell it the same as that, this is why I need one, because the other one makes sense now. Herbivore. So here's the problem. Do all animals fit only in one or the other, or could there be an overlap? And since there can be an overlap, we could, this is all you have to do with designing. You know, either do this, where you say you have a carnivore, herbivore, and then omnivore. You could do this, but for the purposes that I'm doing, because omnivores are just mainly both of these together, this would not be a very good, actually. I guess you could take this and extend this. So if it's a carnivore, then it's an omnivore, or an omnivore is takes all of its properties from the carnivore and from the herbivore. You could do that. That kind of makes sense, what I'm thinking there. I think the other thing to do is just not call it out. And instead of putting things in boxes, that's abstract. When you do abstract classes, what you're doing is saying all of these properties fit in here and all of these properties fit inside. What we can do is we can abstract this layer out even further. And we're going to bring them in. But once I start putting these animals in there, I'm going to throw in some random animals here. So I'm actually undoing everything that I said at the beginning. Like, I usually like thinking high level, but without some concrete examples, it's kind of hard. Right. So with these things here, instead of, so here's the difference between an abstract class and an interface. An abstract class says that I'm here. I'm here, and these things have to fit inside of here. That's what an abstract class says. Because anything that inherits from this is that. And it's only one, meaning I can't have herbivore and carnivore, right? Because we can't do two abstract classes. We can only do one. So we have to pick one or the other. And so if we were doing the abstract class route, we would have to do the omnivore and separate them out more. if I do interfaces, this is the cool thing about interfaces, instead of the fish being underneath the herbivore, you don't think about it like that. You think about herbivore having its own separate properties, and a fish is still a fish, but then this herbivore gets to go arrow, come on. Oh, this arrow. Then you start making your herbivore and your carnivore go to different ones. So this kind of mindset here is what interfaces should look more like. If you naturally put something inside of a bucket, that's an abstract class because you're wanting it to inherit those properties. If you want it to be something that's just an attribute, I can make another one that says swims. If I'm talking about attributes that I want to give to things, like I think polar bears can swim, right? That was not what I wanted. A fish definitely swims, right? So this is kind of what, and here, I'll use my cheat sheet. I think an alpaca is a herbivore. And then I think an aardvark is actually both. So another reason why I want to do aardvark is because it is both. So you can actually have one of these inherit, like having properties of both, just like a polar bear could have a swims and a carnivore. So if you start abstracting away some of these properties, it then I can say, list all the carnivores. If this thing is of instance type carnivore, then I can do something with it. But all of these underneath the animals, I could put in an animals list. And then I can start dissecting, like which they fit in, where the plants are over by themselves. I think aardvarks eat ants. Yeah. My cheat sheet says that they also eat plants. So, I don't know. Hopefully this is starting to see a little bit better. Like you have to think about it visually. Like all of the best software engineers think visually. Whenever you architect, you're drawing it out. This is my frustration. I should have done a better job prepping you guys for the studio last time because I should have drawn it out for you. This is something that I just wasn't thinking. I was thinking, oh, you guys would just draw it out. But I didn't see hardly any drawings. So now let's actually get into some. Right. Now what I want to do is the questions. So I'm going to go kind of fast through this. The first thing I'm going to do is I need some example questions. I'm going to throw this up here. I'm also going to make it bigger. Okay. So we got a quiz. So I'm definitely going to have a quiz. And then let's start actually boxing these. So here's a quiz. Here's a question. Here's a question. And these aren't perfect, so don't get me wrong. Like we might have to change even the wording of some of these, but that's a question. And then this is a question. Okay. So you guys should have been able to kind of like write out a couple questions. figure out, what's the difference between these. I think all of you could agree that each of them have a question. No, over here. No, over here. No. All right, here we go, finally. Question text. So the red is the question text. The true and false could be on there. But let's do the actual question text or statement text. All right, so that's that. They all have possible answers. I think this is where a whiteboard, I would, and this is where like true and false is going to be some of my possible answers. This is the website I'm doing. And so the other things that we might want to know, if you had to get to this, that every question has a question text and it also has an answer. Or possible answer. What? No. Now I see what's going on. It thinks I'm inside the text. That's why. No. Okay. I'm going to click way over here and say possible answers. All right. And then whenever I'm taking the test, there's some other things that come about. One is going to be my actual answer. So user answer. There's also going to be the right answer. Whenever I taught virtually, especially math, I have an iPad. It's a big one, and I used to, I used to write on it, and then it would display. Anyway, okay. Possible answers, user answer, right answer. If you want to give the quiz a name, you can do that if you want to. Okay. So I think these are all, do you see how these are all like nouns? These are answers, text. They are objects. They're nouns. That means these are the things that you are going to call your fields. So fields are your nouns. If I'm going to do something to these nouns, such as one thing I'm going to, actions, I'm going to check answers, right? If it's an action, it's a method. Those are just, that's how it's best. That's the easiest way to like decompose some of these things is if it's a noun, it's a field, a variable. And if it's an action, if you're doing something with the fields, then it's going to be a method. Verbs, nouns. Other actions that I want to do, I want to display question. Something else I want to do is display answers, possible answers. These are actions. That's why I'm still going with them. What else do I want to do? I want to get user input. Yeah, somebody said like grade it. So grade. I'm trying to use vocabulary. Like remember, actions are like methods or actions. So grade, quiz. Now, if you're wanting to talk about a field up here, I can definitely say that one of the fields, one of the variables that we need is we could have a quiz score. And then possible score. So that's how many total you could have. We could display correct and display incorrect. I'm not opposed to that. I did not code that one. I'm a mean teacher, and I don't tell my kids if they got it bad, if they got it right or wrong. They just give them a score and move on. What else? All right. Again, we throw things down, we edit them however we need to. I'm hoping you understand this is not everything I have to do. This is just getting my ideas down. If you did not do this for the studio last week, then you didn't do it right. This is what you have to do. So the studio today, unfortunately, you'll hear me complain a lot about the studio today because the studio today is my least favorite of all the studios. And this is all you're doing. They want you to maybe implement some code, but you actually don't have to have any running code. But if you can do this for the studio tonight, I would be extremely happy. Marking out what are the fields, what are the methods. The next step on this is to tie these together and figure out what my classes are. But the first thing I have to do is get like that mile-high view of like what's even going on here. And now I need to start focusing in on like, well, how can I separate these? Where do these actually fit? So now that's my next step. But again, the studio tonight, definitely think about them, but they're talking about DVDs and CDs. And I don't know how many of you have actually played or, held a CD. So there you go. So this is phase one. Phase one is just writing it out. What does it visually look like? What can I do? Those kind of things. Now what I need to do is figure out, well, how do I, what classes do I need? So I can go back and forth all I want to, but I need to figure out some classes and what kind of things I need to put in there. So the first class is going to be question. And what do all questions have in them? I think we said all questions have a question, text, and possible answers. That's what all the questions have in there. Now, the hard part, though, is all of these look just slightly different. So the book already told you, but whenever you have things that are similar, this is probably going to be your abstract. This is your abstract view rather than your, you're not going to make a question, you're going to make a type of question. So let's do that. Let's say, okay, so we have this abstract question. We can still, I'm leaving a little bit of room just in case if we need something. But I saw 3 different types of questions up there. Okay. I saw multiple choice. I saw true, false. and I saw, I'm going to call it multiple select. Multiple select. So those are the types of things. And now I got to figure out, well, what makes them different? They all have text. They all have possible answers, but can I differentiate them somehow? So let's say with my question text on multiple choice, my is also going to say like select one. My question text here is going to say select true or false. And then the one over here is going to say select more than one. That's how I'm differentiating with my question text. My possible answers. Well, let's see. These have the possible answers is going to be a list, but I don't really know much about it. This one is definitely just going to be true, false. But this one also is going to be a list. What else? Use my little cheat sheet over here. So I have this. I think that's probably close to it. So I have possible answers, correct answers. So check answer. The rest of them are going to be methods. Every question. So these methods here, like check answers, oh, the scores. All of these are going to have scores. So I'm probably going to put scores up here. There's every question has a score, but then you're right, score. We get to decide what our score is. Multiple choice, let's just do that as a one pointer. You either get it right or wrong. Same thing with true or false. But because you can select multiple of these, let's have the score be the number of correct. Like the number of possibly correct answers. Oh, that's what we didn't put in here. So all of these have possible answers, but they also have to have a correct answer. This is a little bit different too, because the correct answer for multiple choice is not going to be a list. The correct answer is just going to be one. And actually, the way that I set mine up, I don't like how they set theirs up. I did mine as a character, or technically a string, but I'm going to say a character. So it's A, B, C, or D type of thing. Here, this is going to be true or false. 4. So it's only going to be one, but it can be either one. Here, I'm going to say A, B, C, and A, B, and C. So meaning like it can be a list. Right. I think I have at least enough. The only other thing that I did was actually getting the user answers. So what I did, instead of making my question do that, this is, I would not have expected any of you to do this, but off to the side, I actually created a separate class, user input. What did I call it? Yeah, handler. I did this. I did a user input handler where I got all the user input. So I didn't have to worry about messing with it in here. I actually made its own thing and abstracted it away. So you guys will see that here in a second. If we don't start getting to some coding though, some of you will start getting bored. So let's go ahead and do that. All right. So on this lecture, remember to create a new project, I just go to new, and I do module because it's all kind of inside of each other. I'm just going to go ahead and call it. Actually, I'm going to do it as a quiz. So let me do a directory. I'm going to call it quiz. I don't know. And then let's do it here. So then new module quiz, it's inside my lecture 7. All this stuff looks fine. That's fine. Well, the problem is I've already done this once. So let's say, let's do this then. All right. Oh, it said it already, I don't even know what's going on. All right, so I have this quiz demo. I just have my main. I'm actually going to change this. I don't like having main. I like having it some kind of runner. So because this is a quiz, I'm going to call it my quiz runner. I'm going to continue anyway. Hopefully that doesn't hurt anything. And it runs. Okay, step 1's done. I get a running program. This is legitimately, this is why I'm going kind of slow through this. If you didn't create a new program and instantly see this hello world, then you're assuming that your code actually works. You're assuming that things happen, and you will have bigger problems later. So anytime you write something, run it. You're always seeing, did what I just do actually work? So the first thing I'm going to do is probably create a question class. And again, this is going to go pretty fast. The design was more important to me. I'm going to call it a base class. And some things that I did not say before, but many of you already kind of got. I'm going to copy and paste a lot of things. I think these are all the things that I put in here. Let's go ahead and change this back to, yeah, let's change this back to question. Right. You see how I did not implement these? Remember, when you do not implement, you have to use the word abstract. Come on, don't do that. What did it just do? All right. Public, abstract, void. So remember, this is abstract. Oh, that's because my class was an abstract. Okay. You cannot put an abstract method inside of a non-abstract class. No wonder it was throwing a fit. All right. Abstract. All right. I actually know what I'm doing, and it took me that long. So you can figure out how long it'll take you guys to do the same thing, just so you know. Right. Again, one of the key concepts you do need to know. First of all, I'm making this an abstract class because in our design, where's our design? I said that this abstract question is going to go to all of these, right? So because of that, I'm making this abstract so that these things can implement it. So that's what I'm doing. And I think before we did point value and text. This is like question text. I think most people got that. This letters, this is what I did. I went a little overboard. Whenever it did the questions, I wanted to not have to type out much. And so instead of doing numbers, I did letters. And what I did was I put these in order so that whenever I actually call them later, it'll be in order. I'll show you what I did there. But this is just a get text and a get point. Once they're set, I don't need to set them later. So I think this makes sense. I do want to call out, though, that these right now are abstract because whenever I display their answers and I get their answers and I display their questions, that's going to be different for each of the three. So I don't want to set this right now because they're all different. Getting a point value and getting a text are the same, so I don't care about that. So then let's actually make one of them. Let's do I'm going to call this checkbox because they did, and then I'm going to change it here in a second because I want to show you a cool tool that IntelliJ has. So if I go here, again, I'm going to copy and paste this. I will talk you through what I did. Again, it's throwing a huge, so the array list, I just need to import in. But right here, it's saying, what do you mean by this override? What are you talking about? And it's because I didn't actually extend this. So I need to say that it extends my question. And now it knows what it's doing. So again, we have possible answers, correct answers, possible and correct answers. Technically, we have time. I might actually put those up here, because if all of them have it, you might as well. Display question, though, I am overriding it because I want it to say multiple select. I want it to be unique. I want to say multiple select. This is a multiple select question. And then this is where I display my answers, my possible answers. What I did was in my questions, those letters that I did, my A, B, C, D, E, whatever, I said, go ahead and print those out with my possible answers. You'll see what that looks like in here in just a second. And then I said, check my answers. So if my correct answer contains my answer, I'm going to add a point. If it's not there, I'm going to deduct a point. This one's unique for this one because I could have said A, B, C, D, E, and F are all correct. And this would have given me full points for it. It would not have deducted my wrong ones. It would have only accepted the right ones. So if I'm only looking at correct answers containing answer and then doing plus, if I do not deduct the wrong ones. So for instance, on my question, I think this will make sense more if I'm here. Whenever I say which of the following are in the 4 pillars, if I select classes and that's not in there, it wouldn't hurt me. So I could have said all 5 of these are the 4 pillars, and it would have given me all the points. it would not have deducted the ones that I got wrong. So that's how I decided to do this this thing here. And then I did say, well, don't go in the negative. So if my correct answers are greater than or equal to 0, here's my correct answer. However many I got's rhyme. Else, give 0, because if you chose the wrong ones, I don't want to give you negative points for that question. So that's how I made the negative there. And then the get answers, this is where I do need to implement this user input handler. Because again, that's what I do, is I make things complicated. First of all, I need to. So this input handler, I will briefly go over this, but I'm not going to go over it too much because this is my fancy way of doing this. Whoa. All right, no more red. Good. So what I did was I said, hey, for each of my inputs, I actually need it to be slightly different. For instance, the only one, you can see that this is grayed out. This one's grayed out. So the only one that I am getting right now is get checkbox answers. And it's going to say, hey, make a new array list because I can return multiple things. I'm going to tell them and prompt them, hey, your answers need to be separated with commas here. And then what I'm going to do is I'm going to take and I'm going to split their answers with their commas and put them into an array or a list, an array. And then for each of those, I'm going to trim it just to make sure that if they did A space, comma, space, B space, it's going to trim out all those spaces. And then I'm going to add it to my user answers and return it back. It's not checking it here. It's just gathering my user answers. That's what this handler, and it is very common in programming to have handlers, just like this. It's handling certain aspects of code, but it's not really specific to any one thing. So this handler, it's a handler. So in my checkbox, now that I had this handler, it's not red anymore. Now, again, I didn't create the handler. I didn't create an instance. I didn't say user handler equals new user handler. I didn't do that. I didn't need to do that because the get checkbox answers is static. So I don't have to create it. So again, just throwing out a bunch of vocabulary out there. So I don't need to do this. I could do it, but I don't need to. So I'm going to do that. It's going to get checkbox answers. Now, again, I've made one of the things. So why don't we go ahead and test this? So I need to go back to my quiz runner. I can print out hello world if I want to, but let's make which one is this? The checkbox. That's this one. So I just use that same thing. The problem is I don't have a quiz yet because I need to make a quiz. So it doesn't know what a quiz is. So I got to make the quiz. I am trying my best to get something that I can actually run. That is my #1 goal. Every time I program is I am trying as fast as I can to get to a running code. That's not, okay, array list. I know. This, I think whenever I looked around, these are all the same. You have an array list of questions, you have a score, you have a total. I think whenever I looked around, most of you had that. Whenever I make a quiz, I'm going to set the questions. At first, I'm not actually going to have any questions, so this will just be an array list, the 0, 0. I'm going to, every time I have a question, I'm going to add the total up. And then anytime I add a question afterwards, I'm going to add the question into the questions array, but then I also have to add the point value for it. So anytime I add a question, I'm going to do that. And then the run quiz is whenever I do this thing here. That's what I'm going to do here in a second. And then I'm going to update the score, which is you just update it every time, and then you can grade the quiz. So that's what I'm going to do in this quiz runner. Now that I have a quiz, now I get to actually do it. So I'm going to run my quiz and grade my quiz. And I'm going to put more questions in there in a second. I have it at a working code, hopefully. This says multiple select, separate answers with a comma. Which of the following? Because I know which ones they are. I'm going to select the 3. And it says you finished the quiz, 3 out of 3. Great question. Trim does remove it only from the beginning and the end. So I'll show you that code again. I'm actually trimming it not at the beginning and the end, but I'm trimming it as I separate them. Here's a debugging tool. Here we go. This is a great part to look at a debugging tool. I'm going to rerun this with the debugger. So when I go here, instead of hitting just run, I'm going to say debug. And right here, it says that it hit here. It says get the answers from the user. Okay, there's not much here yet. So I'm going to hit, there's these arrows right here, these blue arrows. Step over means that it just goes to the next line. That's your most common one that you're using. So I'm just going to step over and it says, hey, now I have an array list of nothing because I haven't answered the question. And after I hit this next one, it's going to ask me for my input. So then I have to go back over to the console. So here's the debugger. Here's the console. It printed everything out and it says separate with commas. So I'm going to say A, I'm going to put some spaces and B and C. Then I'm going to push enter. And as you can see here, my input has all of this stuff with spaces. My trim is on the inside here. So whenever I go inside here, it's only going to grab A and it's going to trim A. So I trimmed A. I'm going to add that to an array, and then it's going to go grab the next one. Well, my next one is B, but it has a bunch of spaces. But because I'm grabbing them individually by separated their commas, that's what this split is. I'm separating by commas. It's going to grab the B, but when it trims the B, it'll get rid of all the white space around it. So again, my answer was the whole thing, and now my answer is just the trimmed value. And then when I do C, the same thing. It has some space there. When I trim it, it trims it down. So that's a great question, and it allowed me to show you the debugger again, which I think is always good for you guys. Let's say that I want to get out of this debugger, but I want my thing to still run. If you hit the green arrow off to the side, it says resume program. It'll just keep going with your program. So if I hit this, it'll actually finish out and it'll say you only got 1 of 3. So again, for the A and B are correct answers, but because I made an incorrect one, it said you got 2, but you missed 1. So that's why my score is 1. Anyway. All right. I'm passing fast because I've already done this. So yes, but do you see how I'm pushing play? Like, I think sometimes you guys never run your program until you think it's actually right. You have to get over that. You have to push play as often as you can. Only do one thing, and as soon as you get one thing, then start adding. So now that I know that my checkbox thing works, well, first of all, I think I complained about this last time. Checkbox is the worst question. This is horrible wording. I don't want it to be checkbox anymore. So here's a cool IntelliJ trick for you. I've already done all this code. If I just went here and I said I don't like checkbox, I like if I can spell right, multiple select. That's what I want. Well, and now I got to change it, and I don't know how many different places. This is horrible. This is why people don't refactor code, right? Because it takes so long to manually do it. So what I can do is I can say, hey, this checkbox, I'm going to refactor it. So there's this refactor, and I just want to rename it. So at the very top here is rename. And then I get to just right here say, I want to change this to, do you see how it's changing it right here? It's actually changing my file name off to the left. It's changing this as I do it. Multiple select. That's select, if I could spell. That's what I wanted to change it. And of course, anytime I do this, I need to rerun it to make sure that it works. So A, C, E. 1 out of 3, perfect. I aced that quiz. So now let's add the other ones. The other ones should be pretty straightforward. So multiple choice, not multiple select, but multiple choice. Multiple choice. And again, I'm going to get my cheat sheet over here. And remember, multiple choice needs to extend question. And it says, if you extend this thing, you need to implement some methods. So it is forcing me to implement these abstract methods every single time. So just know that that's how it has to be. Now, again, I have my cheat sheet over to the side. I'm going to repaste mine. This is exactly the same as the one before. You know, I'm setting point values. I'm displaying questions. The only difference on the display question is this green text. Instead of it saying multiple select, it says multiple choice. Only one right answer. This thing here is the same way I'm doing the letters A, B, C, and D with the separator there. Is correct is a little different. I don't have a list of possible answers. I only have one. So I just need my string, my A, B, C, or D. And if it's correct, it's true. If it's false, you know, if it's not correct, it's false. And then this is where it's checking it. So after I get the answers, is correct, and it's going to ask if it's correct. I'm going to go ahead and do the true false as well, just so that we can get that on there, because I don't want to take up too much time. I'm already taking up a lot of time. But this is the same type of thing. I have my true or false. It's worth one question. Is correct is just, is the possible answer the correct answer, because it's only true or false. And then my display question, it is a little out of order from what it was before, but this one's going to say true, false in the green rather than multiple select. So I'm changing those. Let me see, what else do I need? Okay, so this is everything, not everything, but almost everything I had. I'm going to reset up my runner with my additional questions. Oh, yeah, I don't want checkbox. I refactored that. This is where copy and paste is not always your friend. All right. So here's my questions I'm passing in. When I run this, it says which multiple select, separate with comma, my answers. So A, B, C, D, E, F, G, H, I, J, K, L, all of them. Multiple choice, obviously it's B. And then true or false. Let's do true on that one. So it tells me that my score is 2 out of 5. That's because I totally bombed this one. It noticed that I just randomly put in a bunch of things. So I got 0 points for this, 1 point for this, 1 point for this. Fix. If you're talking about me copying and slapping in code, it's because I have my running code over on my side screen. I only have 3 screens in front of me, so I get to put things wherever I want. All right. The reason I also did those so fast is because I think it's just, most of that is repetitive. There are a couple other things that I do want to show you though. So I'm going to take a pause. I ran my code. I have multiple select, multiple choice, true or false. And then I ran my quiz, I graded my quiz, and then that's what came out over here. When I ran it, it ran it. And then whenever I said grade it, it said my finished quiz score is this. All right. Take a little bit of pause. If you have questions, if you have those thoughts in your head, I'm going to take a drink of water, and then I am going to refactor my code some more for you to show you all the amazing things that we could do. So, and like before, I drink my water and my coffee late at night. Just as a side note, I do like to talk, there's no doubt. So my coffee, the coffee is for me, but I don't know if you guys, I also run some. So like I did a 7-mile run yesterday. I ran only about a mile a day, but if I drink just coffee, I get dehydrated super fast. So that's why like every time I'm drinking coffee, I always have a water cup next to me, because if I don't, I'll feel it on my run the next time I run. So those of you that are at, do activities, just so you know. Yeah. Technically, I am training for a race, even though I don't have to. But no, corporate challenge. Those of you in the Kansas City area, I'm assuming Kansas or St. Louis has something similar, but Kansas City has this thing called corporate challenge. So all the corporations go together and they compete. Most of it, it's just for fun. But I do have a 10K on Saturday. I am so slow compared to what I used to be, but I'm shooting for an hour. So if I can get 6.2 miles in under an hour, that's under my 10-minute pace. So that's what I'm shooting for. And then so Nash, are you going to it? We're going to talk later. I don't want to interrupt too much, but yeah, I do have a lot of hobbies. That's just how life is. Yeah. I used to do half marathons, but I stopped running for about 5 years and picked it back up this year. So it's slowly coming, but it's coming. All right. Let is okay, let's get back on focus, because I'm going to get sidetracked as well. I think you guys have seen me enough to know that I do get sidetracked very easily. I want to show some other things that are possible. I think the hardest part for us right now is to know what is like the best. And that word best is the worst thing that you can do in software development. I can give you two very intelligent architects that have been around for 25 years, and I can say, hey, if I coded this way, is this the right way to do it? And both of them could say totally opposite things. And these are people that have been in the industry. There are no set 100% concrete rules when it comes to software development. The languages change so fast that people just change. Java, it came out to be a very, very over-structured language. And then it started realizing, well, all these other people are switching to other languages. We got to do some things that maybe look something like those other languages so that we can get people back. And they do. So Java has more functional programming. I mean, I kind of showed you with that like stream, the streams API allows you to do more functional things that look almost identical to like the map and sort stuff that you see in JavaScript. So you just need to get something to work first. Every single time. I don't know how many times I can say that. You just get something to work. I don't care how pretty it is. I don't care how efficient it is. You just get it to work. But then afterwards, we can start thinking about how can we refactor this? And it is good to have those conversations. But then again, if you can't think of a way to refactor it, or if your refactoring makes it even worse, then don't refactor it. So what I'm going to show you is some key concepts that I think about whenever I'm doing this. I'm going to go back to the question abstract class. Remember, the focus of this lesson is abstract and interfaces, and I haven't talked about interfaces at all here. So I am somewhat forcing an interface into this project, but on the other hand, it's not that bad. So I'm going to show you when you should be thinking about interfaces. So abstract, if I have undefined methods, these are not implemented in the question class, they're implemented in like the child classes. These things right here, if I only had one, I probably wouldn't even be thinking about this. But since I have multiple, I could technically pull these out and make them their own thing. Now, again, the main reason I would do this is, remember when we were talking about the zoo and we were talking about like herbivore and omnivore, or herbivore and carnivore, and like certain things just fit in different places, and there's not just like animal fit almost everything. So animal would not be an interface. Animal would probably be more of an abstract class because it fits almost everything. If you can fit it into a good category, abstract class might be the way you go. So again, I'm kind of forcing interface in here. I'd probably just leave it like this, but I do want to show you how that works. If you do not implement, then you can create an interface. So let's go ahead and create, and because I am not creative, I'm just going to call it question interface. And all I'm going to do is take these abstract things, if I can grab them correctly, and put them over here. But again, because it's an interface, you do not need this. They have to be public, so you don't have to say public, and they have to be abstract, so you don't have to say abstract. But because I removed them from here, now we got a bunch of red flags everywhere. Like, what is going on here? So then I go up here and I say implements question interface. Now, this question class has these accessible to it now. And not just accessible to it, but do you see how it's not implemented here? It has to be implemented eventually, but that's the other thing is, you don't have to implement it here, as long as it's implemented in these like we already have. So here's a way that I'm doing interface, doing that. Now, the other thing that somebody was talking about, I could potentially make these letters. I don't know. I haven't tried this. Yeah, I can make the letters here so I don't have to worry about having another thing over here. On the other hand, another level of abstraction, potentially, if I have possible answers, let's see. This will either go really bad or really good. Let's make another thing saying multiple answers. Multiple, this is really long, possible answers. And it's going to be an interface. No, it can't be an interface because you don't do these on interfaces. I could do another abstract class. What I was potentially going to do is pull these things out by doing another class, but because they're variables and not methods, I can't do an interface, because remember, interfaces can only have methods, and you can't even implement them, but they have to be methods. They cannot be variables. The only variables you can have are static ones, like these letters never change. So that's why this one works in my interface. Now I could potentially do, put them in here. So let's see if that'll work. So multiple select, when I do that, I'm going to throw these into here. Do you see why nobody likes refactoring code? Like, let's get rid of that interface. Trying to go faster. So we're just going to generate a constructor that has all of them. Makes it a lot faster. Possible answers. Remember the possible answers. So this goes back to somebody else's question. If I move possible answers into the abstract class and I make it private, now my multiple select can't get access to it. So I at least need the getters. I don't know if I need the setters because I don't think I'm going to set it after the question's done. But then right here, I'm just going to say get possible answers. Yeah, get possible answers. Correct answers, it would be get correct answers. That's for the multiple select. The multiple choice now. Remember, these go away. And I'm gonna, is it possible then? Possible first. Oh, do you see how my string, this is why I couldn't pull those away. I could probably do possible answers, but I cannot do correct answers because remember my correct answer is just going to be a string here. Yeah. Well, there you go. I said it was either going to go really good or really bad. Hopefully you guys are at least, I'm hoping that I'm showing you like the thought process of some of these at least. And this is how I think. Like this is just how I do it. I go until something screws up. But if I would have never went down that path, if I would have been afraid, then I wouldn't have gotten there very fast. So please just keep messing code up until it works. I think it's sometimes fun. It's more exciting that way too. All right, I want to do an extremely brief demo. Not demo. No, there's no demo. But I do want to go over the studio. This is so bad. Hopefully none of the IAs are upset that I'm saying this is that bad. Hopefully this is not their favorite studio they've ever done. But what you're supposed to do is a disk project. So you do need to create interfaces and classes. But to be honest, I think drawing is the best one. So if it was me, you need to do something like this. And if you only did this in almost no code, I would be happy as long as you actually understood what you were writing down. Right? So what you're trying to do is you have CDs, you have DVDs. Both of them are, I think they consider an optical disc. So both of those are optical discs, meaning like a computer reads like through lights, it reads the disc. So you're supposed to figure out, well, what are commonalities and what are differences? And then you're supposed to talk about, we talked about this, properties, which are like nouns, like size. Size is a noun. If you were talking about behavior, behavior is like spin the disk. That's an action, so that's a method. So just start thinking about these, about CDs and DVDs, and if you have to Google those, well, I guess you got to Google those. I mean, even I grew up with CDs and DVDs, and I still had to Google them to figure out what are the commonalities and what's the difference. It's scratched, absolutely. Playable, I don't know. So I remember when I did this, it was like we spent the first 15 minutes just figuring out what a CD and a DVD was. So if your IA decides to go off the rails and try to do something else with either like a zoo or something else, I don't really care. The only thing I want you to figure out, find something that you can start grouping things and then separating them. So for instance, if DVD and a CD would be two different classes, they would roll up to either an abstract class or an interface, depending on how you want to do it, and then start just having that thought process. So, because we're getting a little crazy in the comments, but that's fine. I want you guys to have fun. Again, make something like, to be honest, something like this. This is what your goal is. Like, how can you create classes, name their fields, name their methods, do a class diagram.